Hello, everyone. This is your teacher. I'm missing your faces, I have to tell you, and teaching in person is a lot easier than teaching online. But I am persevering, as I know a lot of you are as well, in learning online. So I will take another attempt to make a video that is sensible, and hopefully you can learn a lot. What we're going to talk about today is solving quadratic equations using square roots. The plan is to show you some PowerPoint slides, which have notes on them, and then go through some examples together on this video. Okay, I'm going to pause this and bring up my PowerPoint slides. Okay, so I'm going to share my screen with you, which has the PowerPoint slides on it. Okay, so as you see from this slide, we are going to learn how to solve quadratic equations using square roots. Only certain types of quadratic equations should be solved using this method. As we are going to be learning, there are lots of different methods. If you remember from before the break, there was one method we already learned for solving quadratic equations, and that was the graphing method. I'm going to be referring to that method again today because I want you to see how these two methods are connected. This algebraic method, one of the ones that we're going to learn today, and then the other ones that we're learning as well. So first of all, the types of equations that you're going to solve using this method is there's two different types here. There's this one that's kind of in standard form. It is standard form, but as you can tell, one of the terms is missing. The x term with the b in front of it is missing, which means b must be 0 in order for that to be dropped out. So there's no x term. There's just the squared term here, and then these other things are numbers. The other version of quadratic equation that can be solved using square roots is this one here. This is Vertex Form, if you remember from before. We did a lot with this last semester. Again, you have a squared term and then other numbers around it. All of these H, K, and A, C, and even the Y's here will be numbers to make it an equation that you can solve. So this, anytime you have just a squared term in either one of these, no x term at all, then you can solve using the square root method. Now this vertex form, you could multiply everything out, distribute, and put it into standard form. That was one of the things you had to do before. But then you wouldn't be able to use the square root method if you did that. So what I want you to do is keep it in vertex form. All right, here are the examples that we're going to work through to show you how to solve with this method. The first 5 examples are of the first type, as you can see. They all have an x squared term, but no x term. Everything else is a number. The last 3 examples are in vertex form. You can see it here. Vertex form, remember, is called that because you can see the vertex. If I go back to the previous slide, which I'm not sure, let me go back. Here, this tells you the vertex. This number here is the x coordinate of the vertex. This is the y coordinate of the vertex. H, K would be the vertex. So here in this example, the x coordinate of the vertex is 4 and the y coordinate is 49. Remember that it's always the opposite of whatever's inside. Because this is negative, the x-coordinate is actually positive 4. And because this is positive 5, the x-coordinate is actually negative 5. But we'll see some examples how these all relate graphically so you can compare to the algebraic method. Here are the steps for solving quadratic equations. We're going to, first of all, isolate the square root term by undoing the operations that are around it. And this is what we always do when we're solving an equation, is we try to isolate the variable term. In this case, we are isolating the squared term because once we do that, Then we can take the square root of both sides to undo that square. This is an important note, when you take the square root of something, you will get a positive and a negative answer. If you're given the square root of something, it will either be positive or negative, or both, but generally, when you take the square root of something, it's going to have with it a plus or minus answer. These first two steps pretty much take care of all of those examples that are in standard form. You isolate the squared term and you take the square root of both sides. This third step here is only necessary if you have your equation in vertex form, because once you have done the first two steps, there's still probably going to be a number or two around your variable that you'll have to undo to get the variable by itself. Okay, so we're going to exit out of here and do some examples. Okay. Okay, so I'm going to open up my screen again so you can see what I'm working on with the document camera, and we're going to go through those examples. Okay. So I think what I'm going to do to make this easier and work a little better is I'm going to go through the algebra first, and then I'm going to go back through and use Desmos so you can see some of these, how they're connected. So let's go ahead and set up our notes like we normally would in class. Solving quadratic equations using square roots. Okay, by the way, I didn't mention this before, but one of the beauties about a video lesson is that you can pause it anytime if I'm going too fast to catch up, or to just take a break if you need to. All right, so example number 1 was on that second page of this PowerPoint, and it is 4x squared minus 100 equals 0. Okay, this is in standard form. It's got the squared term, the x term is missing, but we're going to solve it using those steps that we went over. So we want to isolate the squared term. And to do that, I need to undo this minus, and I need to undo the multiplication. And I'm going to work from the outside toward the variable that I want to isolate. So I'm going to add 100 to both sides. We know this, right? And I get this to go away, goes to 0, and I get 100 on the right-hand side and 4x squared on the left-hand side. One more step to undo multiplication. I have to do division so that that cancels out. I get x squared equals 100 minus 4 is, 100 divided by 4 is 25. And then now that I've got the square term isolated, the second step is to take the square root of both sides. Taking the square root of a square cancels out the square. They undo each other. Just like adding 100 here undoes the minus 100, and dividing by 4 undoes the multiplication by 4, taking the square root undoes the square. And so I get x equals plus or minus, and the square root of 25 is 5. It's actually plus or minus 5. And the reason why it is plus or minus 5 is because what this actually means is what number times itself gives you 25. Well, I know 5 times 5 is 25, but also negative 5 times negative 5 is 25. So both of these, that 5 and negative 5, are answers. Okay, we're going to go on to the next example. I'm going to circle, before I forget, that that's our answer right there, plus or minus 5. Okay, number 2, It says x squared plus 25 equals 36. Okay, so I'm going to subtract 25 from both sides. I get x squared equals, what's 36 minus 25? You should get 11. Okay, now I take the square root of both sides. I get x equals plus or minus the square root of 11. Now 11 is not a perfect square, so I can't simplify this answer any. It doesn't have any perfect square factors either that I could simplify, and so I'm going to leave my answer like this. This is the exact answer here. If I wanted to know what that is as an approximate answer, maybe I just can't picture what square root of 11 is, then you can put that into your calculator, square root of 11, and you will get an approximate answer, plus or minus, again, 3.317. This is your approximate answer because we have to round the decimal. Okay, I'm going to go on. The next example is 3, and we have 2x squared equals 0. All right, so let's take a look at what happens here. I'm going to divide both sides by 2 like normal. That gets that to cancel out, and I get x squared equals, what is 0 divided by 2? It should be 0. I take the square root of both sides, and I get x equals the square root of 0. What's that? It's just 0. There's no plus or minus 0. It's just 0. And so this is the case where you will only get one answer when you take the square root of 0. So let's note that. You'll only get one answer when you take the square root of 0. Okay. Let's see where my mouse went. There it is. Okay, I'm going to pause this for a minute. So I'm going to take a look at Desmos so you can see how these examples look when we do it graphically. Let's put the first equation in. And we have 4x squared minus 100. Remember when we solved it graphically, we want to set it equal to 0. If you look back at example number 1, it's already set equal to 0. And then you just put in that piece that you want to find the zeros of. If we zoom out, you can see the whole parabola. It's long and it kind of goes all the way down to negative 100 because that's the y-intercept. That's where the vertex is. But what we want to focus on when we're solving graphically, if you remember, is where it crosses the x-axis. And you can see right here it crosses at negative 5 and positive 5, just like we saw in example number 1. Example number 2 also gave us 2 answers, and you can see if I put in, remember you have to solve it for 0. So if I solve that equation for 0, I get x squared. And I think it would be minus 11. And that's what we get. But again, we have those 2 answers, and you can see that's one of the zeros. That's the other 0. Those are the 2 solutions to the equation we found. All right. The last one is 2x squared equals 0, so it's just 2x squared, and you can see it just sits here on the x-axis that only has one solution. We've seen examples like that before where you have a parabola that has the vertex either coming down like this, but it's up here on the x-axis, and so you only have that one place where it's a 0. Notice here that the y-intercept is 0. Okay. Okay, so we saw there graphically that how it looks when you have two solutions and how it looks when you have one solution. Remember, there are three different kinds of solutions for quadratic equations: 2, 1, or 0. So let's take a look at an example where we are where we get 0. So I'm going to share this with you. The next example, number 4. Looks like this. It's 4x squared equals negative 20. Okay. So I want to again isolate the square term. Divide by 4. That cancels. I have x squared equals negative 20 divided by 4 is negative 5. So I take the square root of both sides, and I get x equals plus or minus the square root of negative 5. Now, if you put negative 5 into your calculator and take the square root of it, you will likely get an error. Most calculators that I've seen cannot handle that because this is not a real number. In the system of numbers, this is not what we call a real number. We call it a complex number because this will never cross the x-axis, and you can see that if we graph this in. So I just want to put up here, if you're going to graph the equation set equal to 0. So to set this equal to 0, I would have to write 4x squared plus 20 equals 0, and then I want to graph this piece right here. So I'm going to share a different screen and go back to Desmos if I can find it. Here we are. And okay, so I'm going to type in 4x squared plus 20 as I wrote it down before. And you can see it's up here. It crosses the y-intercept or the y-axis at 20, and it points up. Remember, parabolas either point up or point down. This one points up, so it's not ever going to come back down and cross the x-axis, so it's not ever going to have a solution. This is how it looks like. All right. So let's go back to the other examples. Question or example number 5. Okay, at this point, I would like you to take a look at example number 5 and see if you can solve this example, see how far you can get. Pause this video and work out the answer. And I will show you the solution in about 5 seconds, long enough for me to have a sip of coffee. Okay, so if you worked it out on your own, you should have done something like this. Subtract 5 from both sides. 7x squared equals 89 minus 5 is 84. Divide by 7, and you get x squared equals 12. And we can take the square root of both sides. We get x equals plus or minus the square root of 12. Now this is a perfectly fine answer, but it can be simplified. Although 12 is not a perfect square, it has a perfect square factor, and we want to take the square root of that factor. So I'm going to show you the step-by-step method for simplifying this, but if you understand what I'm doing and want to skip all these little steps, you can do that. All right, so I'm going to rewrite this in terms of its factors, and I'm really going to pay attention to the perfect square factors first. I know that 4 is a perfect square and it is a factor of 12, so I'm going to write 4, and then that makes it times 3 to give me 12. These are the same thing. The square root of 12 is the same as the square root of 4 times 3. And this is the same thing as saying the square root of 4 times the square root of 3. Splitting that apart is allowed when you have multiplied terms. Only when you have multiplied terms can you split this apart. And now I can take the square root of 4, which gives me 2. I can't take the square root of 3. It's not a nice number. It's one of those decimals that go on forever. We call those irrational numbers. So here's my answer, plus or minus 2 times the square root of 3. This again is the exact answer. If I want to approximate it, then I need to put into my calculator 2 times the square root of 3. And I get approximately plus or minus 3.464. This would be the approximate answer. Okay. I'm not going to graph this one. So let's go on to the other one, number 6. Number 6. This is one of the ones in vertex form. And it's x minus 4 squared equals 49. 49. Okay, remember the first step is to isolate the squared term. This is the squared term. It's all by itself squared. There's nothing added to it. There's nothing multiplied to it. So it is already isolated. And so all we have to do is take the square root of both sides. When we take the square root of a square, that whole thing goes away. They cancel each other out. And I have x minus 4, just bring that straight down, equals plus or minus the square root of 49 is 7. Okay, this is one of those examples where you have a little bit more to do because we still have stuff next to our variable, which we need to get rid of. So I need to undo this subtraction, and I'm going to undo it by adding 4 to both sides. So that goes away. I get x equals 4 plus or minus 7. Okay, this looks a little strange, but I want you to see that I'm putting this in this order. It's always the number that's by itself plus or minus the other number. The plus or minus kind of goes in the middle here. This does give me 2 answers, and I need to figure out what they are, and probably the best way is just to write it out longhand. I have a cat here that wants some attention, so if she pokes her head in, you'll get to say hi to Paku. This is the same as saying 4 plus 7, or you could say 4 minus 7. 4 plus or minus 7. And so 4 plus 7 gives me one of the answers, and 4 minus 7 gives me the other answer. All right, so I'm going to stop this for a minute and go to the Desmos website again so you can see what that looks like. So I'm going to put this in parentheses, parentheses x minus 4, close your parentheses, square. And to get that equal to 0, I have to subtract 49. Okay, so there's my parabola. If I kind of zoom into the x-axis, you can see that one of the places where it crosses the x-axis is at 11, and the other place is at -3, just as we discovered. Okay, so let's go back to, first of all, let me show you if you would like. Paku doesn't want to play nice right now, but I'm sure she'll come around here eventually in front of the camera. Okay, so let's go on back to the document camera and do the last 2 examples. Number 7. Okay, number 7 is 3 parentheses x plus 5 squared equals 75. Now, okay, so we need to isolate the squared term this time. And we got to get rid of that 3 times 3 here. So we have to divide by 3 both sides. So that goes away. We have x plus 5 squared. 75 divided by 3 is 25. And now I have the squared term by itself, so I'm going to take the square root of both sides. Remember, this just brings it down. The square root and the square disappear. And so then what I have left is x plus 5 equals plus or minus 5. Last step, subtract 5. And I can write x equals negative 5 plus or minus 5. Again, try to get in the habit of writing it in this form so that the plus or minus answer comes second, so that when I'm going to figure out what this is, it's a little bit easier to understand. And when this gets more complicated, these square roots get more complicated, this is the standard setup. So x is going to equal negative 5 plus 5, or it's going to equal negative 5 minus 5, and I get for one answer 0, and the other answer negative 10. Okay, so that's my answer for number 7. I'm going to go back up here and circle my answer for number 6. Don't forget, you can pause at any point to just take a moment to absorb everything, or if you need a break. But we're almost done. We have one more example to do. Example 8. 2 parentheses x plus 3 squared minus 10 equals 30. Okay, so I am again going to ask you to pause this video and see what you would do to solve it. Let me zoom in a little bit. Okay, what would you guys do to solve this? See how far you can get with it. Take your time, pause the video, and I will come back in 5 seconds again. Okay, so what you should do if you're going to solve this is undo the minus 10 by adding 10 to both sides. That goes away. You have 2 parentheses x plus 3 squared equals 40, right? Now we divide by 2, and we get x plus 3 squared equals 20. We take the square root of both sides. We get x plus 3 equals plus or minus the square root of 20. How many of you remembered the plus or minus there? And then we have to subtract 3. So we get x equals negative 3 plus or minus the square root of 20. Now, if you got this far, pat yourself on the back. This is great. There is actually one more step, because 20, although it is not a perfect square itself, has a perfect square factor, and so it can be simplified. If we were to break 20 down, we could think of it as 4 times 5. Just like 12 was 4 times 3, 20 is 4 times 5, and so I can take the square root of this 4, that can be simplified, and what I get is negative 3 plus or minus 2 root 5. The 5 stays inside the square root. Okay, this is a perfectly fine answer. If I want to figure out what that is as a decimal, I'm going to do this on the calculator so you can see. All right, so we're going to put into the calculator negative 3. Let me turn it on. Clear. Negative 3 plus 2 times the square root of 5, and you get one of the decimal approximations. I'm going to say approximately 1.472. That's one of the answers. The other answer is negative 3 minus 2 root 5. See how they need to be put in the calculator? Negative 3 plus 2 root 5 and negative 3 minus 2 root 5. That gives us the other answer, which is negative 7.472. Okay, those are our 2 answers. You've got, actually I should have written this down here. Here's the exact answer, here's the approximate answer, and you have your solutions. Okay, that's it for the instruction. I'm going to stop recording this, and then I'm going to upload it to Teams and along with an assignment.